moving on with more work on electron transitions, the next step to this really is to recognize two important things. One, when an electron transitions, an electron will, if it transitions between and goes down, it has to lose energy, and that energy will be emitted, as a photon. And the photon, that photon of light could be any color, because of course I'm doing my trick there of trying to draw a photon as a packet of wave energy. So it's not an enormously long wave, it's a little chunk of wave energy, it's a photon. And remember that the energy of a photon is given by E equals hf. So that's that pen rubbish, I'll just swap it out. So the energy of a photon is given by E equals hf. So in this case, if there were values given here, I would do, that would give me sort of E4 minus E3 equals hf. And if I've got numbers associated with these energy levels, I could subtract between the two to find the energy of the available photon. Now, it would be possible to have an equation like this sort of spun round so that you were said, we've got an electron here and it absorbs energy. White light goes through and it absorbs the photons that are just the energy, just the right size energy for this gap, and it will jump up. So you're saying, so this first thing we've described is light is emitted. So a photon is emitted, or we call this emission of a photon. Now, down here, we could do absorption. Should that be a P? Oh, God. Absorption of a photon. And so, if I shone white light in, the only photons that would be accepted here to provide energy for this transition to move my electron up to there would be the ones that match this gap. So they'd be the photons for which E3 minus E1 gave me the frequency. So only the ones where the frequency matched here could be absorbed. So we'd have just one line taken out of the white light. So if you looked at the spectrum of the white line here, it was perfectly complete. And then on the other side of this body of gas, you'd have a spectrum with a line missing for that particular transition. In reality, there'd be loads of transition options, so there'd be a whole series of lines taken out. But the point I want you to make is that an electron can go up if a photon that matches is absorbed, and an electron can go down in an entirely random process. An electron can fall down and it can then emit a photon. And I probably should have drawn that as a kind of lower energy photon, because I'm needing you to think that if it does a bigger transition from E4 to E1, that would be a more energy photon, which would be a bluer photon. Or maybe an ultraviolet photon. There we are.